हरिः कर्ता।
So we have seen just now we have seen pair plots. Now it's time to move on to the next step under feature relationship analysis, which is parallel coordinate plots. We will be doing parallel coordinate plots now. So what is a parallel coordinate plot? uh, Parallel coordinate plots display multivariate data on parallel axis. So this type of visualization is used for plotting multivariate numerical data. So parallel coordinate plots are ideal for comparing many variables together and seeing the relationships between them. For example, if you had if you had if you had to compare an array of products with the same attributes, comparing computer or car specs across different models. So in these kind of applications, if you if you have to compare if you had to compare an array of products with the same attributes, such as comparing the specs of computers or specs of car across the different models, then this is the perfect fit. So that is the reason we are also looking into the parallel coordinate plots. Okay, in parallel coordinate plots, an each variable is given an axis, and all the axes are placed parallel to each other. So each axis can have a different scale, as each variable can be normalized to keep all the scales uniform. Values are plotted as a series of lines that are connected across all the axes. So this means that each line is a collection of points placed on each axis that have all been connected. So you can see that here we have the three variable, and each variable has taken a separate axis. So variable A, variable B, variable C. Okay, and either you can have a separate scaling for each axis or each variable, or you can normalize and bring them all together to normalized scale. However, the line is very important. What does this line mean? These lines are plotted as a series of lines that are connected across all the axes. What does this line mean? This means that each line is a collection of points placed on each axis. So each line is nothing but a collection of points placed on each axis. This is from here to here. You'll have a variable A, and then variable B, then variable C data points. Here basically you'll have a collection of points. So if you take up variable A has 50 and 30, and variable B has 150 and 100, variable C has 2.4, 2.4 and 0.5. So now the first point is marked, that's 50 for the first line. So this row will take one line, this second row will take another line, and the third, if you have a third row, that will take a third line, and if you have a fourth row, it will take a fourth line. So I hope you got the point. So you have three columns here, or three features. That's why it is very important in feature relationship analysis. You have three features here, and each feature has taken an individual axis. Now it has a two rows. That is the reason you got two lines. Okay, so that's how. So each line is a collection of points of each feature. Each feature. And you see that the line 1 has taken 50, 100 and 2.0, and line 2 has taken 30, 115 and 0.5. And this is what your parallel coordinate plots. The order the axes are arranged can impact the way how the reader understands the data. So one reason for this is that the relationships between adjacent variables are easier to perceive than for non-adjacent variables. So reordering the axes can help in discovering patterns or correlations across variables. So parallel coordinate plots are useful for visualizing the relationships and interactions between multiple numerical variables simultaneously. So patterns such as trends, clusters or outliers can be identified by observing how the lines behave across the axis. Now, how do you create a parallel coordinate plots? To create a parallel coordinate plots, we can use a parallel coordinates function from the pandas. Okay, so that's what we'll be doing. So parallel coordinate plots are useful for several purposes in data analysis and visualization, or specifically for feature relationship analysis. One is visualizing multivariate relationships. This is very important point with respect to the feature relationship analysis. So parallel coordinate plots allow us to visualize and explore the relationships and interactions between multi-numerical variables simultaneously, or multi-numerical features simultaneously. By plotting each variable on a separate axis and connecting the data points with lines, we can observe how the lines behave across the axis. This helps us identify patterns, trends, clusters, or outliers in the data. So next what we have here is comparing groups or categories. Parallel coordinate plots provide a way to compare the behavior of different groups or categories within a data set. By assigning different colors or line styles to different groups, we can easily differentiate and compare their patterns on the parallel axis. So this can help identify differences or similarities between groups and understand how that feature contribute to those differences. And the third one, identifying a feature importance. Very important point with respect to the feature engineering. However, it can be used in EDA, identifying the feature importance. So parallel coordinate plots can be used to assess the relative importance or influence of different variables in a data set. By examining the spread, range, or variability of the lines on each axis, we can get a sense of which variables have a greater impact on the outcome or target variables. So variables that exhibit a larger variations or distinct patterns across the axis are likely to be more influential. And the next one, data exploration and outlier detection. So parallel coordinate plots allow us to visually identify outliers or anomalies in the data. So outliers appear as lines that deviate significantly from the general pattern or exhibit unusual behaviors across multiple variables. By you visually inspecting the lines, so we can spot these outliers and investigate further. So now it's time to get into the action with the real world data set. So let me scroll down. This is 5 parallel. This one for us is parallel coordinate plots. And let me import the required libraries first. Let me import them. So import pandas as pd, import matplotlib dot pyplot as plt, then from pandas dot plotting import, very important one, parallel coordinates. That's it. The importing of this is done. Now let's take up the data first. So let's make a data with the just three rows. Okay, so data of dot iloc, and let me say 0 to 4, and so 8 to end. That's it. So let me just print the data and see. Let me name this to data 3 3r and execute. Yep, this is what is our data. Let's see, you got the pH, sulfates, alcohol, quality, and color, and this is what is our data. Now let's try to create a parallel coordinate plot for this. So for that, obviously we require a species, we require a colors, we require a categorical variable. So let's create the parallel coordinate plot. So parallel coordinates, that's what is the method. Let me say data underscore 3r and just say color, and that's what is our categorical variable out of our whole data set. And let's display the plot. Let me say plt dot show and execute it, and here is your plot. And fantastically, okay, it got three rows, three rows. You got the three lines. Let me bring it down to 2 and let's see how it looks. Let me make it 3 and execute, and here it is. Let me change this to 2r, and here you got the two lines, 1 and 2, and the pattern, you can see how the data across the data set. Obviously that's how from ph. So how this guy, if it is for example an employee data or anything, so one entity's data, and the how the attributes of that entity is varying across, how the attributes of that entity are varying across, that's what we can get. And here you can see the pH is high, then sulfate has down, and again the alcohol has gone up, and then quality, of course. So how to read this plot, that's what I'm just showing. Now let's try to uh, create for the more points. Let me bring it down. Let me make it to maybe 50 lines, and let's see how it looks. 50 directly. Let me say 50r, and here I am gonna say it 51, and this one would directly become 50r and execute it. And let's see, here is your data set. I don't want to print the data set. Let me remove this, and here is your plot, and this is what is your parallel coordinate plot. And you can clearly see a same pattern has been repeated. The same pattern has been repeated. Let's increase it, and let's see what's going to happen. Let's increase it to the 500 rows, and let's see what's going to happen. Will it, the same pattern has been repeated again? You see that? Of course, you have to keep this categorical variable in mind with respect to that it has been made, and you can see that. Even if I go with the old data set, let me go with the complete data set. That's a 6,800 rows, and let's see how it goes. Let me say all are, and here also let me put it all are. It's gonna take some time because we are including, yep, by and large the same, but the only thing is here pH and sulfates, there is not much of difference across the data set, along the data set, across the data set also not much of difference, but specifically along the data set, pH not much varied and sulfates not much varied, whereas alcohol there is a huge huge distribution is there, and then even quality. What you can make out first thing is a range. From here you can see the range. Obviously you can make out the range. If you see, the alcohol range is pretty high and sulfates range is very low. So that's how even you can find out the outliers also. So this is how the parallel coordinate plots can be useful in feature relationship analysis.